In this video, we'll solve a little bit complicated problem where we prove that square of any integer is of the form 3q or 3q plus 1. So what is missing here? Here we are missing 3q plus 2, which means that square of any positive integer will never be of the form 3q plus 2. Okay, so this is what we are going to prove. We prove that any positive integer is of the form, square of any positive integer is of the form 3q plus 1 or 3q. Okay, so let's take this one. So let a be any positive integer. Okay, so let a be any positive integer. So we want to prove when I square this a, it should be in the form 3q or 3q plus 1. So now tell me, what will you divide a by now? So a will now be divided by 3. So if I divide a by 3, so let me write this one. So let me write it here. A, when I divide by 3, it will be of the form 3q plus r. Since I am taking any positive integer, so now r can be of the form 0, r can take values 0, 1 or 2. Please understand, here it is not restricted as positive, even number or odd number, nothing. So any integer, so which means r can take values, all the values 0, 1 or 2. So now a can be either 3q, this is our case 1. Okay, case 2 will be 3q plus 1, case 3 will be 3q plus 2. So here we have 3 cases here. So in all the cases, when I square this, we want a to be in the form either 3, okay, q, okay, since q is already used in the question, I'll just write this one as 3m. Here integer is, here quotient is m, so it will be 3m, 3m plus 1 or 3m plus 2. Since q is already in the question, we'll use 3m, 3m plus 1 and 3m plus 2. So what we need to prove, when I square all the 3, we want to prove that the final whatever you get, it should be in the form 3q or 3q plus 1. Let's see if we get this one or not. Square this one. So a square will be 3 times 3m whole square. So by laws of exponent, you can take square separately. So this becomes 9m square. So 9m square, see this one, how I'll write, since 9 can be written as 3 into 3m square. Since m is an integer, m square is an integer, m square multiplied by another integer 3, this again whole thing is again an integer. So this whole thing now is an integer, so therefore it becomes 3 into q. Some q is another integer which is 3m square. Correct? So now we proved that if a is of the form 3m, the square of a is also in the form 3q. Let's see this one, what happens. So let's square it. So when I square this one, this becomes 3m plus 1 whole square. Please don't write this one as 3m whole square plus 1 square. This is of the form a plus b whole square. So what will be a plus b whole square? A is 3m and b is 1. So this becomes a square plus 2ab, 2 into 3m into 1 plus b square, which is 1 square. So now we expand this one. So this becomes 9m square plus 3 2s are 6m plus 1. So now if you see between these two, we can take, don't take 3m outside, since we want in the form 3q plus 1. So we will just take 3 outside. So if I take 3 outside, here remains 3m square plus 2m plus 1. Now see what is this one. M is an integer, m square is another integer, 3m square is again an integer. 2m, m is an integer multiplied by 2, this is again an integer. 3m square is an integer, 2m is an integer. So this whole thing is again another integer. So this, since whole this thing is an integer, I can write this one as 3q plus 1. Okay. Now this is a little tricky and interesting. So now let's square this one. So a square. So when I square this, this again will be of the form 3m plus 2 whole square, which is of the form a plus b whole square. So a plus b whole square will be 3m whole square plus 2 into 3m into 2 plus 2 square. Now let's see this one, what happens. 9m square, 3 2s are 6, 6 2s are 12m plus 4. Interesting. In these two, yes, I can take 3 outside because I want in the form 3q. okay, plus something. But if I take 3 outside here and I got q, but here I have 4. Now how do I get rid of this 4? So what we have to do here is that you write this 4 as 3 plus 1. 12m plus 3 plus 1. Now you see, in all these 3, now you can take 3 outside. So when I take 3 outside, this becomes 3m square plus 4m plus 1 and this plus 1 outside. Now you see, what is this whole thing? M square is an integer, 3m square is integer, 4m is another integer, 1 is again an integer. Integer plus integer is again an integer. So therefore this can be written as 3 into some q is an integer plus 1. So you took a in any positive integer, which could be either 3m plus 1 or 3m plus 2, but when you square it, answer will be in the form either 3q or 3q plus 1, but not 3q plus 2. Okay, I hope you understood how to prove this one. So whenever you have questions like this where there are different cases, you need to verify that for all the cases that the answer remains valid.